Okay, for this story, I'm going to be talking about when you should be using explicitly defining types if you're using type inference, because type inference is going to determine what your types are automatically, but sometimes that just doesn't work. Okay, there's three different generalizations of when to use that, and that's variables, when you're defining variables, when you're defining functions, and when you're defining objects. So I'm going to start out with variables here. So the first case is when you're calling, when you're using JSON, a lot of times in calling objects that return JSON, they don't know what is going to be returned. So let's say we're defining this JSON constant, and it's the structure like this, X and Y and 10 and 20. When we call the JSON parse with the JSON object, we're going to get a return on here, but it's going to be an any because we don't know, the parser doesn't know what that JSON is. It's just not smart enough to know that. So we want to get rid of any's. We don't want any because that's not specific enough. We're using TypeScript and we want everything to be more specific. So in order to change that, we want to specifically, explicitly define what the type is. So we can define X and Y with numbers here, call the method, and then if we look at the coordinates, constant, we can see that it's got a type on it, which is exactly what we want. Second case is if we're when we declare a variable on one line and initialize it later. So here we're declaring an array. We're setting some values in that array, and then we're just defining. We're going to be searching through that array down here, and we're defining that we found a specific word. We're going to look for a word, and let's say the word is green here. And if we found the word, we're going to set it to true. Well, we don't want to set it to true up here. If we set it to true up here, then we would know that found word is a Boolean. But since we have to set it down here, we don't know what it is specifically. So if I look down here, we see it's an any, which is a big bad thing. We don't want an any. So what we need to do is, instead of depending on type inference, we need to give the type here with Boolean. And then if we look down here, we see that it's Boolean, which is exactly what we want. Okay, the third case is with variables whose type cannot be inferred correctly. Okay, so there's a couple different scenarios on that. Here's one. Let's say that we define an array with numbers and we want to search for the number that's greater than 0, which would be 12, okay? So we set a variable number above 0, and we're going to say that that's false initially, but if it's true, if there is something in there, we want to set it to, we're setting it to the number that it specifically is, so that when we print it out, it would say 12, okay? Well, the problem is that you can see we got an error here. The problem is that since it's a number or a Boolean, as it's false, we're gonna get an error because type inference can't figure out what it is. Here it's saying it's Boolean, but here it's saying, hey, type inference says it's Boolean, and here you're giving it a number, so that's a problem. So we gotta specifically say what type it is there. So instead of here, we're going to say, look, it's a Boolean or a number. That's how you do that in TypeScript, Boolean, and then number. And then we define it to be false. And then we down here, we see we got exactly that, number false. So that's, sorry, number or Boolean, number or false. I'm not sure exactly why that says false instead of Boolean there, but I'm gonna take that as it is for now. All right, next up is functions. In the case of defining functions, let's say we're going to define this function here, and we define it without any types. If you look at it, we got an any, we have no types on the parameters that we're passing in, and we got an any on the return type. So that's just not what we want. So there's no way for type inference to know what kind of or what types you're passing in without defining them specifically. There's just no way for it to figure that out. So instead of, we're going to go ahead and define these types when they're passing it in, and you can see that we have the types defined here. Great. A is number and B is number. What we don't have is, well, and what we also have is the number as a return type too, and I didn't define it. So that looks good. We don't need to define the number here because type inference figures out that A and B are both numbers and returning A and B together, and that's going to be numbers, so we don't need to define number, and that's why it says number here. But watch out, because what happens if you forget to put a return statement in your function, which is exactly what the second case is referring to here. So in this function here, I wanted to subtract, and I know that I forget to return the subtracted amount. So if you look at the function here, it's going to say void, which is not what we want. We want it to return a number, just like we did up here. So to prevent that from happening, we want to go ahead and, just as a general rule, define a type, return type for functions as well as a perimeter type in case you forget to put the return. So we put the return type in there, and even if I forget to put the return in there, it's still a number. Well, it's actually giving me an error here right away to say, hey, you know, you got to return something. That's exactly what we want to see. And we can see that it's a number here in the type definition of the function. All right, this is same goes true for defining a function in the other syntaxes of defining function, which is here using the function name. See, we're also again getting the void. We don't want that in case we forget to return. It's going to be void, so we're going to specifically define it here as such with the number, and then we get, again, same way, we're going to get a number as a return type. Great. And syntax of an anonymous function here. Also, again, another way to define a function in JavaScript now. So here we can see that it's also void by default if we don't define a type and if we forgot to put the return. So let's go ahead and define a type here of number, and then we can see that it returns number just like we need. Great. And then another scenario is that when we have returned of null or undefined, how are you going to define what type are you going to give to your function if it's returning null or undefined? Well, the answer is void. Void still works for those cases. So if I uncomment this line, I'm returning null with this function here. No errors, everything's fine, it still works, it still returns null. Instead of returning null, I can return undefined, same thing, everything works, there's no errors, and it returns null, no problem. So just use void. Lastly, a rare scenario is when we have a case when we're not returning anything, when we're just throwing an error and actually never gets the return, never returns to the calling function or calling code. So here I show that if I do that, we show that it's a void, which is a bit misleading. We'd much rather say that this never returns anything. Again, this is a very rare scenario. So there is a never keyword in TypeScript. It's to never return anything, and if I highlight it over here, we see never, and that's exactly what this is. It just returns a error. And then lastly, third scenario here is destructuring functions. Okay, that's the when we have to be a little bit more careful about, and it's a little bit more tricky when we're using TypeScript. So this function here is we're first defining an object with a structure, okay? Object literal. And here we're gonna, down here, we're gonna, I'm sorry, right here, we're going to define how the calling function will look like. We're taking in a forecast, we're taking this specific object, and we're going to get out the date and the weather out of it, okay? And down here, we're calling it, okay? And I called it today's date because that's what we defined what was in it. And this is just the structure of what it's expecting. So, of this function. So if we look at this function, we can see that it's returning null. That's good, but we define null, but it's not. It just says forecast for the parameters, and we want to know more details. You know, what do you want for the parameters in there? So that's not good enough. So we want to add some TypeScript in there, which is pretty normal. So let's do that here with a second. It's just the same scenario we had up above, where you need to define every function with parameters with types. The only difference is that this is is an object literal, so the types are kind of embedded into another object. So what we're doing here is now defining, we're saying what the forecast object is. It's exactly what this is up here, which is a date and then a string. So we defined that type for this parameter. And now if we come down here and look at this, this is great. It's got exactly what we want. We want the types in there of the parameters, so it looks good. Okay, the only thing we might want to do is we might want to, instead of having to call forecast.date and forecast.weather, we might want to destructure the call, the parameter right here within our function definition. So that's what I do down here. And here you can see that all I did was, instead of adding the function, I added the destructured function, or sorry, instead of adding the forecast variable, I added the destructured here, you know, into the destructured type, so that we can just pull out the date and the weather more directly. But what we need to watch out for here is that basically the way we did it helped us because we already knew how to give the type here. But remember that we're giving the type of the destructured object completely outside of that, the destructuring. We're not giving it within, we're not trying to define the date here. That is wrong, okay? We're not defining the date outside of it in a completely separate destructured TypeScript object. Okay, and then we're moving on to objects. Dealing with objects here, I have a object literal, and I've defined it to be a person. We're given the name of the person is Alex, and then everything else is to be defined, or to be set, to be initialized. So we got an age, we got the coordinates of where that person is, and that's second level deep, where we got coordinates dot latitude, coordinates dot longitude. And then I'm setting the age. I have a function to set the age within our object, and then I make another function to set the coordinates with our object, which is going into a second level deep. Okay, what we're dealing with here is destructuring the first level deep of an object literal. So that's going to raise a little bit of different settings in our declaring TypeScript. So we see here that the profile is set to set age is 20, and down here we're setting profile age to 20 as well. And down here at the console, we're going to print the age, okay? But what we can see here is that the age is any, and we don't want the age to be any because we want it to be more specific and a more specific type. So we need to type something here. So we realize that we're gonna, without destructuring and with Typescript, we're going to give a type for age. And when we do that, we can come down here and we can see that age is a number, and that's exactly what we want. But what we did not do is we did not destructure the age as we were doing in our last over here in the functions. So if we wanted to structure the age so that we don't have to call profile.age to get the age, we can just call profile. We can destructure it this way, okay? But then again, we got the problem because the age is still an any. So we need to destructure the age and Typescript it. But this is not how you do it. And it's basically very similar to what we did before in this function section. But we kind of intuitively say, well, age is a number, and we just put number over here. Well, that's not true because this is a destructured object, and we need to show a destructured way of Typescripting it. So instead of just saying number straight out, we need to define which particular property in the object is a number. And here we define it here to be a number, and then the error goes away. So now we've restructured the object. We've gotten to the age without having to dig for it. And also we have it typed. So the age is a number. So that's good. Now we got some really good clean code. And finally, we'll go into the second level deep of the variable. We want, it's a little bit more complicated. So here we're setting the variable to 0 and 15, just like we did up here at 20, so that we're not setting the variable within the object. So Typescript cannot tell that what it is. It doesn't know what type it is. So when we come down here and we look at the age, it says, sorry, that's the number. We did that correctly, but we come down here and we look at the latitude and the longitude. It doesn't know what they are because they're set in a different method that they were set, that they were, or sorry, they're initialized in a different line that they are declared in. They're declared up here, and then they're set down here. Same thing with the age initially. So that's part of the rules that we went through up here with when this is the second rule of when we need to use explicit typing. So here, instead of just expecting type inference to do its job and figure out what these latitude and longitudes are, we're going to use Typescript with destructuring again and define a destructuring Typescript object here. And it's a little bit more complicated because it's second level deep, but that's how you do it. And there we can see that's a number, and that's also a number, longitude and a number, and I didn't have to dig through the profile to try to find out what they were. It just destructured them straight away. Okay, and lastly, when initializing a type object with objects literals. So if we have a function that, let's say it's a print person function, and here we're printing the person down here, okay? We're calling that function that we defined up here, okay? And here we're saying what is a person? A person is just somebody with a name with a string, okay? So if we define P to be Freddie, just the name of Freddie, and we call this function here, we can see that the P is, it's expecting a person, but the P passed in is, sorry. The P passed in is just the name. It's just a string with a name. We don't know if it's a person or not, so that's not specific enough. It could be problematic. So let's go ahead and, oops, sorry, what did I do there? Let's go ahead and take a next step. Oh, let's see what exactly could be the problem. Well, I could say that the name is 7. I could mistakenly give an incorrect type to the name when I'm passing it in here. When I define it, and then when I pass it in here, it says, hey, you know, you're passing in the wrong type. Well, how do I know where I went wrong? It's giving me the error down here. You should be passing in, you know, a string, not a number. But actually my problem was up here, so it'd be a lot better to know right away when I was setting up here that that was the problem. So instead of letting type inference trying to figure out that, hey, this is you know, wrong down here, we should be sure that we define it where we're initializing our variable. So if I say here, hey, person is a name of 7, and we if I define it to be a person here with TypeScript, and we say its name is 7, it's going to give me an error right away. Hey, that's not good. So that's bad, and I'll go ahead and change it in the second line, or the last line here, to be of a string type, and then everything's good, and we got a problem figured out on the line. The problem was not in a ladder function. So that's it for this story. Thanks for watching.